What is this, Lady Ada?
Hey everybody, and welcome to a weekly show and tell, the most fun you can have on the internet with all your clothes on. It's us, me, Lady Ada, with me, Mr. Lady Ada. We're here at the Adafruit factory. We've got all the electronics and manufacturing we do here, but this is a half an hour where you, the viewer, are going to show up and show off your project, whether it be 3D printing or crafting or making or electronics or hacking or coding, whatever it is. Come by and show it off. We're going to be here till 7:55. Take a few moments when we call on you, show off your project. Demo it, have a good time, and we'll get you a sticker. All right, let's kick it off with Dave A.
Hey, Dave.
Hey, guys. So a couple things tonight. One is this little paper helps, which is Feather M0 Express running CircuitPython, manipulating the Dotstar Featherwing. And I have a guide to the library I wrote, the CircuitPython library I wrote, that is almost ready to go. So
is it like a snow globe type thing?
It's a little Christmas scene animated, some flashing snowflakes. And
that's nice.
So that'll be coming out in the next couple of days. Also, the big thing I have this week is this, which looks like something TSA wouldn't let me on a plane with. But it is a prototype of my next generation smart home node, which has a Feather M0 Wi-Fi running with a real-time clock wing, an OLED wing for some status information, which I don't think you can make out with the camera, no. And also a custom wing that has a motion detector, PIR, a NeoPixel for status, and a CDS cell for light level. And so when this starts up, it talks to the Ethernet, hooks up with my local network, talks to Hue to find out where my U unit is, talks to that to figure out what the lights are in the room that it's in, and then takes over those lights to control them. So when it senses motion with the PIR, it checks the light level. If it's dark enough, it'll turn on the lights. Also, I go out to darksky.net to figure out when sunset and sunrise and sunset are for today. And if it is between sunset and sunrise, so it's dark out, it'll automatically turn on the lights when it sees motion. And also hard-coded at the moment is sort of bedtime and get-up time. And if it's in between those, it'll turn the lights on dim rather than full brightness. So this is the prototype. And my idea is to push more of the intelligence, more of the decision-making out to these edge nodes rather than having it on a central machine.
Neat.
So
okay.
I'll be doing a guide to build this, too.
Okay. And thanks again for doing the Son of It guide, Dave.
Oh, no, that was fun. That was good. And there's more to come on that, too.
Yeah, good stuff.
Displaying Chinese characters and so forth.
Yeah, we're getting it translated and...
I heard.
Yeah.
Cool.
Yay, thank you, Dave.
All right, next up, Chris. Chris, how you doing?
Can you hear me?
Yeah, we can hear you.
All right. Click minimize. Wake up. Click minimize. Go to sleep. Okay, here we have a 3D printed Christmas ornament that I created. I tried to get on a couple of weeks ago to show this off, and you guys were full, so I'm glad to be here. It's a icosahedron, 20-sided thing with little spikes glued onto it. Here's the individual parts. I printed the core in 2 different pieces, and then you got 19 spikes, and then the 20th one, I put a little ring on it so you can hang it up, and you glue the spikes onto the 2 pieces, and then you glue the 2 pieces together, and that's up on Thingiverse right now. Here's a couple of other ornaments that I created along the way. A little twisty ball, I call it. Here's a solid infilled twisty ball. It's not really solid. It's a hollow shell, but you get what I mean. This is a little snowflake that I made. The symbol in the center is called the Enneagram. It'd take me all day to explain to you what it means, but that's why it has 9 points instead of 6 points. And this was a real challenge to print. Normally I print things with Simplify 3D from the inside out, and it has an option to print from the outside in. And going outside in, it defined the perimeter better and printed a little easier. Getting it to stick was hard then getting it unstuck when you were done was hard. And it was quite a challenge to print, but it was really fun. Then finally, here's my annual computer-generated Christmas card this time. I did a 3D printing theme, speculated that perhaps Santa Claus has adopted 3D printing. I modeled the printer sort of loosely based on a CR10. It's a relatively inexpensive printer with a large build area. I figured it would be great for Santa's workshop. You notice there's a little Adafruit printing on the one in the foreground. We've got some race cars, some rocket ships, all different toys. We've even got a little screen capture of simplified 3D in the hands of the one elf there in the foreground. Now, a lot of my friends and family don't have 3D printers, don't know what 3D printers are, have never seen anything 3D printed. So I made them a little trinket, and I stuck it in their Christmas card. It's just a little piece of Christmas holly. And I edited the file to put a different name on each one and stuck it in their Christmas card. I had to do it in Blender. Fusion 360 is terrible at trying to get text to center just right. They really need to work on that. But I still had a lot of fun. People really appreciated it. They've already posted Facebook messages to me of their little green ornament hanging on their trees already. So I've had a lot of fun with that. Finally, here's me 1 year ago this week. Live streaming from my hospital bed, and lucky to be alive. And a year later, I still feel very lucky to be here. I've done a lot of really creative work over this past year. I've done the Bluetooth switch control tutorial. I've got RLib running on Circuit Playground, both in C++ and in CircuitPython. So it's been a really productive year for me, and I'm glad I've had that opportunity to share what I could with the community. I promised a year ago that I would, and I've been able to fulfill that promise. We have one more anniversary. This is me 5 years ago next week, the very first time.
That's our old apartment. I see it.
Show and tell.
Yeah.
So this
I was so young and thin back then at the bottom there. Boy.
Yeah. And then here's you guys, a little pinker and a little less gray back in your apartment. But that's you from that same show 5 years ago.
Yeah, we're
so
pretty
anyway,
easy to spot if you're a time traveler. You can just go to the shows.
Yeah. So anyway, it's been fun sharing with everybody. I'm looking forward to many more years of it.
All right. Well, thank you so much, Chris. You know what they say, if you travel long enough, you meet yourself.
Yeah.
So here we go.
Where was it? Where was
This
that?
was at
401?
this is at 80 Nassau Street.
Yeah, that was more than 5 years ago.
Yeah.
I think it was.
Well,
Yeah,
long
we're,
time ago in an apartment far, far away.
yeah, we were a tiny company 5 years ago. Now we have more new friends. All right. Thank you so much, Chris.
You're welcome.
Thanks,
Man,
Chris.
I got to stop eating those Halloween cookies and
We got a lot of cookies.
Christmas cookies. Okay. All right. Next, BlitzCity. Hello, BlitzCity. How are you?
Welcome back.
Hey, how's it going?
Yo.
So this week I soldered up PiHut Xmas Street kit. I know with the webcam, like the lights aren't going to really show up that well, but I swapped in slow changing RGB LEDs for the red ones that come with the kit. And since it's hardware, the light is what changes the color. They slowly get out of sync. So it comes this like really multicolored thing. It's running on a Python script on the Raspberry Pi. And then the other thing I'm working on, I'm hoping to have it done by Christmas, is I did a 3D printed Santa ornament. So I printed it in white PLA, and then I've been painting the parts. So I finished that up last night, finished up the eyes. And the back, I've got a cutout for electronics. And what's going to be in here is a speaker, a trinket, and a little button that's going to play like 8-bit music when you press it. I just haven't built up the circuit yet, but I've got the code. And then I just have to print a back plate to close everything up. I've been having a little trouble sizing that up. I'm still pretty new to Fusion 360, but I think tonight I might get it. So I did get the sizing right for the speaker and a 2.5 millimeter screw, so I was pretty happy with that. But yeah, that's what I've been working on.
Cute.
Okay, and excellent work on all the guides. Lots of people are making some of the snow globes and more. Oh, there's a cat. What's the cat? What's your cat's name? I haven't seen the cat before.
Oh, I have two, Winnie and Harriet.
Winnie and Harriet. Okay.
I did one of them just.
Yeah, well, we have to ask because we have the Cats of Engineering section on our site. So Scott asked.
Oh yeah.
Yes, cats. We have cats. Everyone seems to have cats.
Yes.
Okay.
Cat people rule.
Next up, CodingPro. Welcome back. Happy Halloween.
So I was asked to make a guide for Adafruit, and I made last time I made that other not last time actually, I made another Christmas box. This time I made a new one for the guide. It's a Christmas box. I don't know if you can hear it, but the back has a Gemma M0, some electronics, battery, and it has a vibration sensor, so if I hit it, it lights up and plays some music. And once the music stops, it turns off.
Okay. Nice. Simple but effective.
And it's like good for giving a little gift of electronics. I don't know. It'd be a fun
All right.
You can also put it under the tree, and like when people they always shake the present, it'll play something.
You're getting electronics.
It'll scare them, especially if you're trying to sneak in to listen.
That's a good idea.
Yeah.
All right, good work.
All right, thanks,
and as always, of course, Dave, Chris, BlitzCity, and CodingPro email supported Adafruit will send you a sticker and all that stuff or more.
Okay, thanks, CodingPro.
Okay, next we're gonna go to Aidan. How's it going, Aidan? Good to see you.
Aidan.
Hey, so last time I was on Show and Tell, I was on the other side of the camera, but now I'm back. I'm in my workshop and I have a new project. So one of the things I was talking about when you had me on the show was how much I really like simplifying robotics, and that's why I make soft robots and make really simple mechanisms. And so I have another one today. This is a solenoid-driven gripper that I've designed. And if you see, when I activate it, it has a very small pinching motion. And I will fold my camera down so you can see it better.
That's kind of nice, though. It's simple.
Yeah. So if you can kind of see it here, I have this 3D printed Ninjaflex mechanism, one of those very tiny solenoids you sell, and giving it 5 volts. And it just lets it kind of have this pinching motion through this simple mechanism with 8 live hinges. And so if I can pick up this little flash drive here.
Grab it from the other side. Yeah, grab it. Grab it.
Hold up. Got it.
Oh, you got it. That counts.
There we go. And so it's got it's not super strong and it doesn't have a great range of motion, but those are all things that can kind of be changed through modifying the mechanics of this mechanism, because essentially it's just a bunch of levers attached to each other, and it's 3D printed as one part, so it's really simple to make, and it's only one electrical component, so it's easy to control. And yeah, it might be something to expand upon or implement in future robots.
I like it.
Yeah, it's kind of simple, elegant, and fun.
Another thing that I like about it is, solenoids are very reliable.
Yes.
They really, because they just have electromagnet and a slug. Inexpensive, easy. You can also mold it. You can, unlike a motor, which is hard to, if you're mass manufacturing, you can create it into the plastic. A solenoid's quite easy to make on your own.
Definitely. Yeah. And also I just feel like solenoids aren't well utilized in robotics. I see a lot of applications where a solenoid could easily replace like a small screw or something. And so I figured I'd make a little use for it.
Hello, yay! Clapping.
Maybe you could use it for a claw machine or something.
Yeah, so I'm actually planning on attaching it to a small laser cut robot arm that I have, and maybe doing some control with it that way.
Maybe we can make the first honest open source claw machine, one that you can actually, that's not you can just get good at it and learn skills. It's not actually meant to separate you from your money.
Exactly, it'll give you the teddy bear you want, finally.
All right, thank you so much.
Yay, thanks, Aidan. Okay,
next up, GB. Hello, GB.
Hey, what is up?
Hey, welcome back.
So, I wasn't here for a couple of weeks because I had a lot of stuff I was working on, but I finally got back to working on this ALU project, and I have quite a lot of progress. So, I built this little ALU, does math, and so far when you said build a RISC processor, I was like, hey, that's pretty interesting. So that's exactly what I'm doing. So and I built my own reduced instruction set. Instructions right here that for bit opcode, and there's 15 of them because it's 4-bit. And this is my first program I ever wrote in it. And all it does is add a number until it reaches FF, and then it'll stop and display it to the screen.
Okay.
But yeah, I put little things here. You see, you have 1 1, which is set A to 1, which is its value and its opcode. Return ALU, which means put ALU to register D, which is like set location 1110 to ALU, which is 1110 is right here, I think. Actually, no, it's right here. And just RAM for setting the B. Then it pretty much compares 12 to the added number. It'll go to well, if it isn't 12, it'll go to line 2. If it is 12, it'll go to right here, display it to screen, and then halt. So that's about it.
Okay.
So hope you enjoyed it.
Okay, sorry. I was so entranced. I have a question. Do you want to expand this to be an 8-bit processor, or is it 4 bits is enough?
I definitely need an 8-bit processor. There's so many more instructions I need.
Yeah, okay. All right.
And if anyone wants to help me write a compiler for this, that would be great, because I'm not good at compilers, and this thing needs a compiler. It's machine code. Because I turn this into machine code over here. It's not fun to write.
Yeah, by hand. Okay,
Yeah.
looks good. All right, well, come back when you've got more bits, or maybe you got more instructions, or maybe, I don't know, you got other things that you're building. I'm excited to see where this computer takes you.
Yep, thanks.
All right, thanks, Phoebe. Don't forget to email support Adafruit to get a sticker.
Okay. Next up. Oh, Rebecca was here, then she's gone. All right. Okay. Next up. Annie, how's it going?
Hey, welcome back. Annie? Hey, unmute your mics and we.
Yeah.
Hey, what's going on?
Sorry about that.
No, it's okay. Welcome.
So last week I came back with this incomplete project that apparently wasn't working functionally. It was related to the Star Wars movie. It was like a little lightsaber on the front of a Raspberry Pi.
Yeah.
Which I then turned into a Chromecast. So if you'll excuse me for a second, I'm gonna have to screen share because I can't see viewer.
That's cool. Thanks for coming back.
All right, so I have it all hooked up over here. So if you'll excuse me for a second, when I go on my phone, there's going to be an app that I'm going to use to then cast it. It's called raspberrypi, where you put in your IP address in this little column, and then it'll directly connect to your Raspberry Pi remotely, and you'll be able to stream any music or videos locally from your file manager stuff. So I have Believer by Imagine Dragons, so I'm gonna play that right here.
Okay.
It's not popping up for some reason.
Do you want us to stop
All
back?
right, hold on for 1 second.
Okay, we got a couple more people that we're going to try to squeeze in. So how about we stop back?
All right.
Okay, so just you keep going.
We're gonna.
All right, we're gonna.
Oh, there it is.
Oh, there we go. Yay!
Yay!
Yay.
It works.
It works. All right, so yeah, that's pretty much it.
Okay.
Yay!
All right. Well, congratulations. Email support@adafruit.com. Just have a parent do that. We'll send you a sticker. All right, we're gonna go to Joey and then JMK. Joey, show your project. You got like a minute-ish.
Hey guys, can you hear me?
Yeah, you sound great.
Cool. So let me just switch this over here. So what I designed was actually a gift for a friend who plays competitive cornhole. And so these are wireless scoring devices. And so let me wait for the other one to reboot here. Actually, I may have screwed it up. But so basically the score is transmitted between the two devices and then displayed on screen here. Are built using Adafruit Trinket Pros, and then the RFM69 modules. And then this was my first printed circuit board that I designed. So that there was really a lot of new concepts for me in 3D printing and circuit board design. But it was a cool project, and I'm glad I got to show it off because I'm going to send this video as part of the present for Christmas. So
wow, what a great gift! It looks so useful.
Yeah, and so they're magnetic on the back, so they can snap right to the board or snap together like that, so you can travel with them.
Nice. You're a great friend, making useful stuff for people.
Yeah, that's one of the things I love about making.
Yeah. All right. Well, congratulations. We're going to send you bonus free sticker that you can put on your gift before you send it. Email support Adafruit, and we'll send you out an As Seen on the Show and Tell sticker, and they'll know that this scorekeeper was famous.
Great. Thank you.
All right. Thanks, Joey.
All right. Yep. Outstanding. All right, JMK.
I got your suitcase with you.
Hey, how's it going?
Yes, the suitcase is back. So, I think I've showed this before. There's a little Arduino Nano powered suitcase. So what I've done is I've hooked it up to have sort of a thing where there's two little pieces of copper tape on this little thingy-majig. And when you place it, it's a little finicky, but when you place it along this, it lights up the LED just because it's sending a 5-volt signal. But this will be used for is like, yeah, I'll be like walking over there or something, and you put the little thing over the copper tape, and it'll like unlock a door or something.
That's so cool.
That's cool.
Like a little doorbell or something using copper tape. And then also, I got this little cute little thing. So this is a Tiny Screen Plus, which that just came in the mail today from Tiny Circuits. And they actually have a smartwatch kit. But that uses the older version of the Tiny Screen. The Tiny Screen Plus has an Arduino, all that Arduino stuff, so I can code it using Arduino built in. So it's a lot thinner to just make a little portable device with this. And I'm gonna flip the switch, display a little example.
Oh, neat.
Floppy bird's flipping.
All right, so you're gonna make a watch, right?
Yeah. The reason I didn't buy the kit itself is it used the older Tiny Screen, and it would be a lot thinner if I just used the battery.
It's okay. It's like chunky watches are in style right now.
Is this gonna run like a JMKOS thing on it? Like, what are you gonna do?
Well, yeah, I could just it can support bitmap graphics. Just each pixel has to be defined. Actually, oh, my microphone just muted.
Oh, you're back.
Hi.
I can bring up that code, Arduino IDE, where are you? Here it is. I had, let me share my screen. Let's see.
All right, so this is an
Anyway, you have to define each pixel with a variable, which is kind of annoying in the Arduino IDE because each pixel has to have like TS rectangle filled or TR red color or something, which is annoying because each pixel could have a like number or a hexadecimal value, which would be a little better. But anyway, it works.
Okay. Come back and show us your watch next week or next time you're done, okay?
Come back, JMK. Good stuff as always, and have parents send a note if you want another sticker or something else.
All right.
Good work.
Good work,
All right,
everybody.
C. Scott, play us out.
Hey guys, I'll be real quick. I wanted to show you, I got my my module playground boards in, but they came in today. So I didn't have time to put one together. But I did put together, there's a drum machine from 1968 that was very popular back in the 70s, was used by a synthesizer keyboard player from France named Jean-Michel Jarre. This is, it uses a bunch of different
Oh,
there's
head out there for a sec, C. Scott.
Right.
Yeah, so your mic's cut down.
That's cool. So you just see the drum machine.
Yeah, you can see the drum machine running around. This is kind of like making grades. He's got.
There's some.
It's running off of a 328. It's running off of a 320, and it will play.
No, there's music out there.
And of course, you can play along with it. The song that made it. Anyway, I know you're pressed for time, but I'll be back next week and show you with the module playground with the actual DAC working correctly. So
yeah, we don't really do anything else. We're here next week.
What's that?
We don't really do much other than this on Wednesday. So
yeah, okay. Well, you know, I'll let you guys get out of here.
Okay, I think Rebecca dropped and then she came back. Rebecca, if you can do it in like 1 minute or less, we'll squeeze you in.
I can do that.
Okay.
Yay.
Hello.
So I'm home for the holidays, and since Hanukkah's basically over, I've moved on to Christmas gifts. And my parents have finally stopped watching show and tell, which means I can share Christmas gifts.
Oh, there you go.
I have this frame. I've been working on a weather display for my dad, so it'll show the weather for the next day. Whether it's sunny, cloudy, if it's raining or snowing, and then the high temperature for the day. There's cardboard behind it to block out the different light sections because they're NeoPixels.
You can write on it, so you could change it too.
Yeah, so it's paper that's there behind the glass, so I can take that out and change it. The paper's not glued down or anything. And then NeoPixels.
Internet of Things of whiteboards. Surprisingly,
yeah.
It's going to be a Kickstarter next week. So. All right, that's fantastic.
Awesome. Nice work.
Well, if it makes the present better, we can send out a scene on the show and tell sticker. Just email support at. I don't know if that helps.
Stickers make everything better.
All right. Well, thank you so much, Rebecca. Thank you, JMK. Thank you, Dave. Thank you, C. Scott. Thank you, CodingPro. Thank you, Chris. Thank you, BlitzCity. Thank you, Annie. And thank you, Aidan. We're here every single week. Thank you for making not only this year fantastic, but this half hour and every single week. Oh, yeah. C. Scott. And we'll do Ask an Engineer in just a few minutes.
Yes.
And thank you again. Happy holidays, everybody.
Thank you, everybody.
And we're probably going to be here next week.
Yeah.
Yeah, we'll do it next week. Okay. All right. Bye-bye, everybody.
Thanks, everybody.